All right, hey y'all, we are back with another video. Yesterday, some of y'all were making fun of my camera work, so I hope today I'm a little better with it, all right? I'm gonna try. So, yesterday we worked on solving or graphing one equation, right? So today we're going to graph two equations and find the solution for that. And you'll see what I mean in a second, all right? So we're solving systems by graphing. Tomorrow we're gonna solve systems by substitution, which is like algebraically. So before we begin, we have some vocabulary to discuss. So a system of linear equations is just two or more linear equations. Y'all gonna be like, Miss A, your hand's in the way. I'm sorry. All right, so it's two or more linear equations. So y equals mx plus b, you're gonna have two different ones of those. So the solution to that system of equations is always going to be an ordered pair. Ordered. I'm trying to do my camera work good. Ordered pair. All right, is always going to be an ordered pair. So your steps to solving a system of equations is first, graph the first line. First line. And then you graph the second line. And the point where the lines intersect is the solution. We are going to have some situations in which the lines don't intersect or they intersect at every single point. All right, so I'm going to show y'all, and that is one solution, no solution, infinitely many. First, we're going to start with one solution, which is the most common one, right? So we have this equation, y equals negative 5/3 x plus 3. So the b for this, we know is 3, right? You always start with 3. So I'm going to start on 3 on my line, on my y-axis, right? And then my m is negative 5/3. So that negative 5/3 is telling me to go down 5 and to the right 3. So down 5, because it's negative, it's a negative 5/3. So down 5, 1, 2, 3, 4, 5. To the right 3, 1, 2, 3. And I can keep going, but then I'll get off this graph. So I'm going to create a straight line through this entire graph. Some of y'all made fun of my lines yesterday, so I'm going to try my best today. Something like that. Cool. All right. So we got that. That's a straight line. Don't make fun of me. So here is y equals 1/3 x minus 3. Remember, b is where you begin. Your b is always in the back of the equation. It's in the back of the equation. So my b is negative 3. Right? So I'm going to go to negative 3 on my y-axis. I'm plotting that point. B is where you begin. M is 1/3. Sorry. So it's positive, so that's saying up 1 to the right 3. So I'm going to go up 1 to the right 3. Okay? Up 1 to the right 3, it'll be somewhere out here. You need to keep plotting points until you can't anymore. For example, if I go up 1 to the right 3, I could also go in the opposite direction. I could go down 1 to the left 3 and have my other point. It helps me make a straighter line. So now I connect these points. So the point where they intersect is the solution. So this ordered pair right here is 3, negative 2. So that means the solution to this equation is 3, negative 2. It's this ordered pair. That is the solution. Okay? So just where they intersect. Bada boom, bada bing. We good. All right? So now let's look at one where it has no solution. So ones where they have no solution, you're going to have the same slope, but different y-intercepts. So if I see that, I might be able to say it's no solution immediately because the lines are going to be parallel. That means they have the same slope, different y-intercepts. Let's see that. So for the first equation, my b is 2. That's where I'm going to start. So I'm going to go to 2 on my y-axis. This negative 2, remember we have to put it over 1. So that means my m is negative 2 over 1. If it's a whole number, put it over 1. So negative 2 means down 2. 1 means to the right 1. So I go down 2 to the right 1. I do not stop there. I keep going. Down 2 to the right 1. Down 2 to the right 1. I'm going to keep plotting so I can make a line as accurate as possible. I can do the same thing in the opposite direction to continue my line. So if I went down 2 to the right 1, I can go back to my B and go up 2 and to the left 1. and plot that point. All right? And I can't go up 2 anymore, so I'm going to draw my line. So, let's see. Okay. That's a little sloppy. Sorry. Okay? So that's my line. So I graphed the first one. Let me graph the next one. So -2 is where I begin. B is in the back. It's where I begin. B equals -2. So start at -2. All right? M, again, it's -2. We got to put it over 1 because it's a whole number. So that tells me I'm going down 2 to the right 1. So I start at B. I go down 2 to the right 1. I plot that point. I can't go anymore, so I'm going to go in the opposite direction because I'm trying to put as many points as I can. So I went down 2 to the right 1. I'm going to the opposite on the other direction. So instead of going down 2 to the right 1, I'm going to go up 2 to the left 1. Up 2 to the left 1. Up 2 to the left 1. So if I were plotting this, right? If I were plotting this, these lines at no point would they intersect because they're parallel lines. So there is no solution to the system. All right? No solution. They don't ever intersect. They just like, no, stay away from me. All right? Now we're going to have infinitely many solutions. So in this case, y equals x plus 1 and y equals x plus 1. Those are the same line, right? They have the same slope. They have the same y-intercept. It's going to be the same line. 2 lines stacked right on top of each other, infinitely many solutions. So let's see that. So my b is where I begin. It's 1, right? So I'm going to plot 1. My m, remember, in front of this x is an invisible 1. In front of the x is an invisible 1. So my m is 1 over 1, positive 1 over 1. So that means I'm going to go up 1 to the right 1. So, up 1 to the right 1, up 1 to the right 1, and up 1 to the right 1, up 1 to the right 1. Same thing in the other direction. Down 1 to the left 1, 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 down 1 to the left 1. And I can connect those points. Cool. I got that. Now y equals x plus 1, same thing. My b is 1. Let me go this way. My m is still 1 over 1. So I'm going to essentially be plotting the same line. It's going to be like 2 lines right on top of each other. That means they're intersecting at every single point. So it's going to be infinitely many solutions. All right? So now you have 3 examples. Refer back to these examples. Refer back to your notes from yesterday to figure out how to plot a line. And you should be good to go. Bye-bye.